Hello everyone, and welcome back to my channel. This is Vishnu Manjipudi, and today we will be solving the 2018 AMC 8 problems numbered 1 through 5. Let's begin with problem number 1. An amusement park has a collection of scale models with ratio 1 to 20. So scale models, ratio 1 to 20, of buildings and other sites from around the country. The height of the United States Capitol is 289 feet. What is the height in feet of its replica to the nearest whole number? So, this problem is really simple. Since we know that the scale models have ratio 1 to 20 with the originals have ratio 20 to 1 to the scale models, which means the scale models are just 1/20th of the original models. So, the scale model of the Capitol is just going to be 289 times 1 over 20, which is going to be 14 and 9 over 20. And since we want to round to the nearest whole number, this rounds to 14. And let's move on to the next question. What is the value of the product? So here we just want to find the value of this product. 1 plus 1 over 1 times the quantity 1 plus 1 over 2 times the quantity 1 plus 1 over 3 times the quantity 1 plus 1 over 4 times the quantity 1 plus 1 over 5 times the quantity 1 plus 1 over 6. So for this one, what we can do is first rewrite all of these sums as fractions. So we know that 1 plus 1 over 1 is 2 divided by 1, and then we multiply that by, here we have 1 plus 1 over 2, which is just 3 over 2. We multiply that by 1 plus 1 over 3, similarly equaling 4 over 3. And then we proceed. 1 plus 1 over 4 is 5 over 4. 1 plus 1 over 6 is, 1 plus 1 over 5 is 6 over 5. And 1 plus 1 over 6 is 7 divided by 6. Now we can notice here that we can cancel out the numerators and the denominators. So, for example, we have this 2 in the numerator cancels out with this 2 in the denominator. Similarly, these 3's cancel, these 4's cancel, etc. And what we end up with is this product just equaling 7 divided by 1, which is simply 7. Or answer choice D. And let's move on to the next question. Students Arn, Bob, Sid, Dan, Eve, and Fawn are arranged in that order in a circle. They start counting. Arn first, then Bob, and so forth. When the number contains 7 as a digit, so 7 as a digit, such as 47, or is a multiple of 7, that person leaves the circle, and the counting continues. Who is the last one present in the circle? So we want to know the last one. To do this, we can simply brute force it and create a table with all the values. So we begin with writing A, B, C, D, E, and F for Arn, Bob, Sid, Dan, Eve, and Fawn, respectively. And now we begin the counting. Arn says 1, Bob says 2, Sid says 3, and so on, until we reach Arn saying 7. At this point, Arn is eliminated from the circle, and we continue. Bob says 8, Sid says 9, Dan says 10, Eve says 11, Fawn says 12, Bob says 13, and Sid says 14, and is then kicked out of the circle, since 14 is a multiple of 7. Counting continues, with Dan saying 15, Eve saying 16, and Fawn saying 17, also getting kicked out. Now we continue. Bob says 18, Dan says 19, Eve says 20, and Bob says 21. And 21 is a multiple of 7, so Bob is kicked out. So now it's just a showdown between Dan and Eve. So Dan says 22, Eve says 23, and at this point we notice that Eve is going to only say odd numbers and say 27. So like this, so 24, 25, 26, and 27, which means that Eve is going to be kicked out, and Dan is the last one in the circle, which is answer choice D. And let's continue. Problem number 4. The 12-sided figure shown has been drawn on 1 centimeter by 1 centimeter graph paper. What is the area of the figure in centimeters squared? For this, we can divide this figure into 5 components. A central square, as shown here, like this, and 4 triangles, like these. So the area of the entire figure is just going to be the sum of the area of the square plus the sum of the areas of these 4 triangles. Now we first know that the area of the square is going to be its side length squared, which in this case is 3 centimeters. So we square 3 centimeters. And this is going to be equal to 9cm squared. Now, the area of 4 triangles is just 4 times the area of 1 triangle, since we know that the areas of each of the 4 triangles are going to be the same. So we have 4 times the area of the triangle is going to be 4 times, and each triangle, note that has a base of 2 and a height of 1. So its area is 2 times 1 over 2, which is just 1. And this is going to be equal to 4. Thus, the total area is going to be 9 plus 4, which equals 13. Choice C, and let's move on. Problem number 5. What is the value of 1 plus 3 plus 5 all the way to plus 2019, and then subtracting 2 minus 4 minus 6 all the way to 2018? So let's first partition the sum. We have the sum as 1 plus 3 plus plus 2019. So 2019. And then we have this minus, and then here we have 2 times 1 plus 2 plus all the way up to 2018 divided by 2, or 1009. And now we already know how to evaluate each side of the sum. The sum of the odd numbers from 1 plus 3 all the way to 2019 is simply 2019 plus 1 over 2 whole square, which is just 2019 plus 1 over 2, and then we whole square this. And then we subtract the second part, which we know is going to be 1009 times 1010 divided by 2, all multiplied by 2, which is simply 1009 times 1010. Now we can evaluate this fraction to be 1010, so our answer is going to be 1010 squared minus 1010 times 1009. And we can immediately see that since 1010 squared is 1010 times 1010, this value, by the reverse of the distributive property, is 1010 times 1010 minus 1009. And since 1010 minus 1009 is 1, the result is simply 1010. E. And we're done. Thank you so much for watching, and it really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, or concerns, please post them down below, or email me at steamaspirations@gmail.com. This is Vishnu Manjuputi, signing off. Bye.